Hey, this is Greg, creator of the Leptos web framework in Rust. I thought it would be kind of fun today to see how to build your own front-end framework in Rust. Not because you should do this, but because I think it will help you understand the way that the whole Rust WebAssembly ecosystem works, the way that you interact between your Rust code and the browser, and the way that popular frameworks like Leptos, like Sycamore, like Vue, like Dioxys work. We're going to be building a framework that's sort of like a simplified version of Leptos or a solid JS. It's going to use the kind of fine-grained reactive model of signals and effects to build up a framework incrementally that lets us go from writing kind of imperative code where we're working with DOM APIs directly into writing a kind of declarative code that you might be familiar with from your applications. In other words, we're going to stop writing code like this, where we're manipulating the DOM directly, and we're going to start writing code that's maybe a little more like this. So let's say we want something like let app equals L new div dot child L new button dot on click something dot adder ID my button dot text click me. In other words, rather than creating, our elements with document.createElement, manually setting something like text content, appending a child, and so on, we're going to be able to sort of describe what we want with a Rust builder pattern syntax, and then have the rendering library just create it for us. Let's get rid of all of this for now. And why don't I say a few words about what's appearing on the screen. Over here in this left pane, I've got NeoVim, the editor. To the top right here, we've got a little program called Bacon, which I've been really enjoying using recently. It's a kind of Rust diagnostic tool that shows all your errors and warnings, but it just watches whenever you save a file, but it shows the errors at the top, which is a lot easier than reading it in the console where things tend to be reversed. And then down in the bottom pane here, we've got Trunk running. Trunk is a great tool in the Rust WebAssembly ecosystem. It lets you basically take a Rust binary crate, like any other, and an index.html file, and then it basically handles compiling to WebAssembly, injecting the JavaScript it needs to load the WebAssembly, and rendering your web page. So I had that 20-line application. Now we've cleared it out, of course, but you could see how it was rendering that simple web page for our opening screen. A few words about some of the libraries we'll be using. So WASM bindgen is kind of the cornerstone of the current Rust WebAssembly ecosystem. It basically provides the ability to generate bindings between Rust WebAssembly code and JavaScript, hence WASM bindgen. In other words, it allows you to call JavaScript functions from your Rust code and to call functions you define in your Rust code from JavaScript. And this is really useful because WebAssembly doesn't have direct access to the DOM or to browser APIs at the moment, so you call out through JavaScript. The WebSys crate is kind of the other cornerstone here, which uses WASM bindgen to generate bindings for all those browser APIs, for all those web APIs. So things like accessing the window or the document, creating elements, setting text content on an element, this is all done through WebSys. And finally, I will be using Leptos Reactive, which is just the signals library for Leptos. I'm not going to go through, creating your own kind of change detection mechanism or creating your own reactive library. I do have another video on that if you want to see it. But for now, we will just be pulling in Leptos once we want that interactivity to make things a little easier. So, like I said, let's just start with something really simple. I want to be able to basically write code like this. I want to mount something, and what I want to mount is an element, and let's just make it a button for now. So instantly, of course, we have some errors, which are that we don't have L or mount. So let's go ahead and create the L first. So this is basically going to be a kind of wrapper around a WebSys element. In other words, it's just going to be a new type that wraps the native DOM element type. And I'm actually going to go a step further and implement deref on it so that you can basically use this L type as if it were an element. This is convenient for us because it basically lets us implement additional methods on the native DOM element, and that's what we're going to do to kind of build up this declarative builder pattern that I showed earlier. So now we need to create the new function, of course, to create an element, and we also need to create the mount function. So let's go ahead and do new first. So let's create an impl block for our L. New, and new is going to take the tag name as just a string slice, and it's going to return self. So how do we create an element? The first thing we need to do is to grab the window from websys. Whoops. Window is a function that just returns the current window, or returns none, right? Because there may not actually be a window in the particular environment you're running. We're going to do a sort of messy Rust, exploratory Rust, and do just a lot of unwrapping and things. You know, if we're in an environment in which there is no window, there is no document, there's no body, all of these things I'm going to be unwrapping, you know, we should just panic. This is toy code, right? So then we take the document off of the window object, and we're going to take the body element from that document. Actually, we don't need the body in this case. We just need the document. So to create an element, we're just going to call document.createElement, pass in the tag name, and that's it, really. So we've just created an element. Now we just need one more thing, which is the mount function. Let's put that up here. And let's see, it's going to take an L, right? So we'll call that root. It's going to be an L. Now what we're going to do here is I'm going to paste in the window and the document, and this is where we're going to take the body. We'll just mount everything to the body for now. Pin child root. And that should do it, right? Because we implemented deref, append child here, oh, it's not going to give it to us, that's fine, takes a websys element or a node, but because we can deref our L to an element, we can just use it as if it were. Okay, so let's go over to our actual browser and look at that. I'm going to make this a bit bigger so you can see it, but we've created a button. Of course, it doesn't do anything to click the button, but that's all right. We created the element and mounted it. The reason I want to start with a button is that buttons, even if they don't actually have any content, do appear on the screen, so you can see that we successfully rendered something. Okay, so what should we do next? I'm actually going to add an event listener next. And the reason for this is that it's going to let us keep getting some feedback that we're doing something right as we build this up. So for now, I want the API to be something like this. Long. So right here, you see I'm importing the console from websys. I'm just going to log out this string. And basically the API for this is going to be on, then the name of the event type, and then the event that we want to call. So of course we need to go down and implement this now. Pub function on, and we're going to use the builder pattern, so everything is going to take self and own self and return self. Event name is going to be a string slice, and a callback. So this can be anything that implements function mute takes a websys event, and we're going to return self. So the reason for function mute here, it can't be function once. If you don't know the function traits, there are three. There's function, function mute, and function once. It can't be function once because we need to be able to call the event listener, like, you know, every time that it's clicked. It can be function mute. In other words, we can take a closure that that can mutate the contents of the closure. Now this is a little bit messy. There is a glue events crate that may be more useful. I'm going to just do it manually because I've done this a bunch of times. I'm going to use wasm-bindgen closure type. And we have to basically wrap our callback because we have a Rust closure and we need to be able to call it from JavaScript land. We need to be able to call it when that button is clicked. So what we do is we wrap it in this closure type, which, let's see if I can pull up the docs there. Good. Closure is a handle that points both to the closure in Rust as well as the JavaScript closure. And when the JavaScript closure is called, it will invoke the Rust closure, which is exactly what we want. So the way that I create this, there is a closure new function, and I always forget how to use it properly, but the old school way is just closure wrap, and then I'm going to box my callback as a boxed trait object. And then to add this event listener to the self, I can do add event listener with callback, which is a WebSys function. I pass in the event name. And then the second argument here, if we actually look in the docs on docs.rs, I'm going to go to the docs for element, and then I'm going to search for add event listener with callback. There we go. It takes a reference to a function. Function is a type in the JS syscrate, which lets you work with JavaScript objects and things and types from Rust. Basically, we're going to use a trait that's in WAS and BindGen that's called JS cast that allows us to do sort of dynamic type casting between different JavaScript types. It's going to look something like this: cb.asref.uncheckedref. What that does is it basically lets us say, okay, you know, this really is the JavaScript type that you want to take, and just accept that. You know, we can do checked versions of this too. The reason that we need to do this is that, you know, if the browser, if these web APIs were written in Rust, there would probably be something like a function trait, but because they're written in JavaScript, there is sort of class inheritance instead, and you know, our closure type we can sort of cast into a JavaScript function, but it's a different type, and so Rust, since it has nominal typing instead of the sort of structural or duck typing in JavaScript, we have a few little awkward casts like this that will come up over the course of this, but it's not a big deal. This is just how you add an event listener. This is all pretty well documented. Okay, and then we're going to return self, right? Now, this is almost right. Oops, and of course, you see this warning, this error up here. Our callback is going to take an argument, which is the event itself. So we'll take that. Oh, this is why I had been using glue console is another helpful library just for console logging. As silly as that sounds, because all of this like glue code that you have to write is kind of a pain, right? You have to like create a JS value, right, which is a JavaScript object from a Rust string slice in order to be able to pass it to the console log function. Okay, now let's see what the error I'm getting is that, right, this needs to have a static lifetime. The reason for that is that we're passing it over into JavaScript land, right? So it can't have like a Rust lifetime associated with this function because we're handing off ownership essentially of this function into JavaScript, so it needs to own all of its own data. And just so that none of you get annoyed, we're going to just unwrap this so that the warning isn't there. Okay, so now if I pull up my browser and I pull up my console, what we're expecting is to get a console log. What we get is a panic with the exception closure invoked recursively or after being dropped. So it's closure invoked after being dropped is what's important here. When I click that button, think about the ownership of the Rust data types we're creating here. Right? We've created a button. We've called this onClick. But this mount function, right? We have our main function. This runs. Everything it owns will drop, right? This mount function runs. Everything it owns will be dropped when it's done. We append this child, you know. None of this lives after this main function. The main function runs and it's done. But when we go to this on function, right, this creates this CB, this closure object. it adds the event listener by reference. It doesn't pass ownership of it, but it passes it by reference, and then it returns self. And at this point, the closure is actually dropped. And that's why it's telling us that the closure is invoked after being dropped. There are better and worse ways of handling this. Here's the sort of dirty way of handling it. We're just going to call forget, which essentially leaks this closure, but it means that it won't be destroyed. It will still be available to call. And, if you're writing a real framework, you want to do something to clean up after this so that if you create and destroy a lot of events with event listeners, you're not just leaking memory. But in our case, because we're just creating this element once and it's showing on the page, we can just not worry about that. And we're going to reload, and now, good. So now our clicked callback is firing correctly. All right, so let's do 2 more simple things just to be able to start building up an application. The first one is going to be to add an attribute, and the second one is going to be to add children. So let's start with an attribute, which is going to be really simple. So we'll add an attribute. The API is going to be you pass in the attribute name and the attribute value. Let's just keep this really straightforward. Attribute name is going to be a string slice. Value is going to be a string slice. Return self like everything else. And because these are all just static types we're passing in, or they're just things that don't change over time, this is really easy. Just going to do self.0.set attribute, add name, value, and return self. And then we're going to see what errors the compiler gives us. Okay, we actually did that. So now if I pull up my inspector here, you'll see the button ID my button. Great. I want to add one more function. Well, let's say 2 more little functions. The first one is going to be text, and the second one is going to be child. So if we add the text function here, this is, how do we create a text node and append it to a child? So to create a text node, we need to grab our document again. Could we refactor this? Maybe. Am I going to? Probably not right now. Great, so we've got our document, and then the node is going to be document.create text node, which just takes a string slice and it returns a text node. Return self, and we need to append this node to our element. So self.0.append child node. You see how a lot of what I'm doing is basically creating these more ergonomic, more declarative builder pattern type wrappers around imperative functions in the DOM. So when I say l.text, all we're doing is then imperatively creating a text node with certain data, appending it to the DOM, and so on. And now we've got our nice click me button, right? But what if I want to append some kind of a child that is like another element, right? Because I want to be able to put this into a div or something. So let's actually go up here, say l new div dot child, and then take all of this, paste it in here, maybe get some better indentation. Okay, so now it tells me, okay, there's no child method, and fair enough, because there is no child method. So let's go down into L, and again, this is going to be super simple. The child is going to be just another L, and it'll return self. And here, all we're going to do is self.0.append child. And because we've implemented that deref type into an element, we're just appending an element to an element and returning self. So let's see if this works. By the way, this warning, there's this phantom warning about unsafe stuff sometimes with certain operations with websys, WAS, and bindgen. I don't really fully understand it. It's not actually unsafe. Actually, if you suppress this, if you put in the unsafe block, you'll then get a warning saying it's an unnecessary unsafe. So take that for what it is. Okay, so now it looks exactly the same, but you can see we've actually got a div wrapping our button, which is exactly what I want. Cool, so we can now kind of build up a little bit of a of a tree here, because what if I say I actually want something like this? So instead of click me, we're going to do +1 and -1. And then we're going to have a little value field in the middle. Perfect, right? Funny things that you notice, like spacing becomes important, so why don't I put an actual space before there? Good. Right, so now we've got our two buttons. Both of the buttons do the same thing, but these are actually different functions. We just haven't updated them. All right, so we haven't done anything at all to make anything in this dynamic. The obvious next step is for us to do something like this. Let count, set count equals create signal cx0. However, if we do this, we immediately run into the fact that we actually don't have a reactive scope to pass into this. If you're not familiar with leptos, this is just our way of creating a signal, which is a variable, a value that can change over time, and we pass in a reactive scope, but we don't have that. Let's actually change the function, the signature of our mount function a little bit, so that we're providing it in this mount function. So what I want to end up with is something like this, where I can take my context in here and just pass it right in there. Of course, everything's mad at me now, so let's go and actually change our mount function so it works that way. So instead of taking an L, we're going to take a function, which only needs to be called once, which takes in a scope and returns an L. And now we have to sort of create the reactive runtime. So this is the sort of thing that you won't need to usually do on your own in Leptos, but if you're using the framework or something, but it's maybe useful just to see how it works. So we create a reactive runtime, we create the scope, now we've got the scope. We don't have this root anymore, so let's create that, right? Root is going to just be f cx, it's an L, and that should all be good. However, I have to import all this stuff. Okay, and again, this is going to need to have to be static. I constantly forgot the lifetime bound there. Okay, great. So this looks pretty good. Let's just do a sanity check, make sure this is still working. Cool. Obviously, nothing about this changes because we haven't actually told the signal to do anything. Let's finally get rid of this weird warning in our click listeners, and let's do something like set count. Decrement in that one. Let's save a little time and copy and paste it, delete this one, and there we go. I am going to have to import a trait here, I believe. Oops. Dot update. There we go. As if I knew how to use my own reactive library. Here we go. Okay, so now we update them, right? And now I'm getting lifetime warnings. We need to move the signal in there, which we can do. Cool. So now, when we click the buttons, you know, they don't do anything because, of course, we haven't actually told anything to update. So we've got the value listed here, right? This is just a static piece of text. Let's implement a new function that's like din text, dynamic text, right? And what we want to do for that is we'll probably pass in the reactive scope here, right? So it has a handle on that. And let's say something like, you know, count.get.toString. I'm just using the stable syntax here. If you're using nightly Leptos, you can just call count like that, right? But just for the sake of confusion. And let's see, I do need to import that trait. Okay. And of course, now there's nothing called din text. So what is din text going to look like? So this thing that I passed in, right, if you're, whoops, just deleted all that by accident. If you're used to Leptos, you're used to passing in closures like this everywhere. I'll explain why we're going to do that in a second. Let's just create our function signature first. Okay. Din text takes self, takes the scope, and then this is going to be something like a function that we can call over and over again that returns a string and has a static lifetime. Okay. We know we're going to return self out of this, but what do we do other than that? So in a reactive library, if you're not familiar with the kind of signals approach, there are two halves. There are signals and there are effects. Signals are values that change over time. Effects are side effects that run, functions that run in response to those values changing. So whenever we need something reactive, ultimately it's going to be create effect. And if you're just using like Leptos, the framework, or Solid.js or Sycamore, you don't necessarily create a lot of effects yourself because the rendering library is handling it for you, but they're all built out of effects essentially. So what we're going to do is create a text node. So let's go up here, grab exactly the same code to create a text node, right? We want to then append this text node to our parent. You'll notice right here, right, there is nothing called data. Let's actually, for now, just create it as an empty text node. And then we're going to create our effect. And the effect is going to get the current value by calling this function. And it's just going to do node.setData to the value. Okay, so let's see if this works. Yep. So on the initial run, you can see the value is 0. So, and then let's click our button. Sure enough, there you go. Works perfectly. So how does this work, right? How does this work? The way that create effect works is it runs once instantly, calling the function you give it. So it runs, it calls the function we passed in to get this value. The function we passed in calls count.get. Now when you call .get, see this says it clones and returns the current value, 0 initially, and subscribes the running effect to this signal. So what effect is running when this .get is called? Well, the effect that's running is this effect we just created. So that means that when we do this f call, right, when we call the function we've passed in, this immediately subscribes to that count value. What that means is that every time we update the count, we mutate that value and notify the subscriber that the signal has changed, and then it runs again. So we've basically created a really simple cycle where on the initial load, this text node, this effect, right, it's created empty and then immediately filled with 0. And then every time the value changes, it increments. And if you look at what's happening in the inspector here, when we press these buttons, the only thing that's changing is that single text node. Nothing else in the entire DOM is changing. This effect is targeting just that one node, and that's why we call this fine-grained reactive library, right? Now, any library, if you're using a virtual DOM like React or U or something, that would also only modify this node, but would diff against all these other nodes to see if they had changed. And it just does that in the background. In our case, we only touch that one node because we know exactly what's changing. We're not going to do it right now, but we can do things like create din child too, so that we can have conditional logic on on what attribute or what element appears. We can take options so that we can show something or not show something. We can do din attributes that would work exactly the same way, except we can dynamically update the ID or something. But this is the basics of how this works, and how you can go from that imperative code to sort of composing something. You'll notice too, this builder pattern, some people really like writing code like this. Some people actually ask for this out of frameworks, if you're used to Rust and you like this builder pattern. But it's also really, really simple to use this to translate from something like, div. Like, imagine that this is a macro, right? You can see how you could, pretty easily build a macro to go kind of one-to-one from a JSX type syntax like this into a builder pattern like this, because we just say, okay, this is a div, so we'll do L new div. Okay, now it's got a child, which is an element, so we'll do .child L new button. On click, ID equals my button. And in fact, this is exactly how a library like Leptos works. We use a great crate called syn rsx, which provides all of the proc macro parsing to build up a kind of RSX, JSX syntax like this. And it's really handy. I'm not going to do that in this video, because this is just sort of trying to look at the rendering part of it. So here's kind of an interesting question, right? What does a component look like in this kind of a library? And this is, I think, the last thing we'll talk about before I stop. How do you make a component? Well, remember that we're only calling this once. We don't need to recall this function over and over again. This mount function is a setup function that runs once. So we can actually create a component function by just creating a function. So let's call it button. I'm going to call it button with a capital B, although this isn't very good Rust syntax. Let's give it a scope. Let's say it should take a label, which is a string slice. Let's say it should take a callback, which is just a function like this that we've seen, and that should return an L. Well, we know pretty much exactly how to do this. We just are going to basically take code like that, paste it in. Instead of this particular click handler, we're just going to give it this callback, take out the ID, text, label, and this should basically work, right? And then let's use that in place of our two buttons. So instead of that, let's just give it button. Oh, you know what? We don't even need to pass in the scope in this case, but we'll just give it anyway. -1. And then let's take my function here. And sure enough, it works exactly the same way. So this really is the way that that components work in a framework like this. You can do all sorts of extra, fancy stuff because you want to have things like tracing or good, debugging stuff, or maybe there's some extra stuff you need to do in the rendering library. But basically, in a reactive framework like this, a component really is just a function that refactors out part of your UI and creates an element, because things like this din text call, right? This is the only reactive thing in our application right now. But any other reactive stuff is going to be created kind of independent of the component tree. The components really are just functions. This just returns an element, right, which is a wrapper for an actual native DOM element. And then certain things like din text create their own effects and so on but this has nothing to do with the component, right? The component really is just a plain function. If I want to be a good restation, just change this to a lowercase button, right? There's nothing magical about the uppercase. The reason we do that is actually just because it makes it a lot easier to figure out what's a component and what's an HTML element in a view macro. But this is just, a function. So anyway, I hope that this helped demystify some of how a framework like this works. It really is, in our case, a case of just building up these reactive parts of, adding on these methods to allow you to define different things on your element type. It gets much more complicated when you want to include things like fragments and you want to do things like, classes and whatever, but it really is pretty simple and straightforward. So I hope that this helps you understand some of how these frameworks work, some of how the Rust JavaScript interop works in general, and I hope you have a great day.